I'm Dan Bornstein. I'm hosting a series of Tech Talks this month on Authorization Based Access Control, currently or possibly formerly known as object capabilities. We have 4 speakers who are associated with HP Labs, and each of them has a different perspective, a different story to tell, different project to present, or projects to present. With that, we have Alan Karp today. He's the head of the Virus Safe Computing Initiative at HP Labs. And he's going to give us an overview of what his group does and, I guess, talk about a couple of projects.
Yep. Okay, first I got to show you this. We just, every 6 to 9 months, the branding office sends out a new standard format for slides. And this is the new HP branded slide format, so I thought that was pretty cool. All right, so, okay, I have to start with a disclosure. HP has a very active security team. We are not part of that team. HP Labs has a very active security team. We are not part of that team. We are sort of just like a skunk works off in the corner working on security. And the reason is we take a very different view of security than most security professionals do. And I'm going to tell you about some of that today, and you're going to hear more about it in the next 3 weeks. That's okay with us. The rest of the world is crazy, and we're the only ones who are sane. And my goal here is to disinfect you of the world's craziness and infect you with ours. So just put that in perspective. In order to demonstrate the value of our way of thinking about security, we decided to do what many people would consider impossible. We decided to make a virus-safe computing environment for Microsoft Windows. You guys can stop laughing now. We have it. It runs. Our beta release is out. Okay? But the operative word is safe. You see, we're not going to detect the virus. We don't block the virus. We don't change the operating system. We don't touch the applications. We just let the virus run, but it doesn't hurt you and you don't spread it to others. And if we succeed in doing that, we'll have made virus writing uninteresting, and that's the way you win this war. Okay? Now, this is a security talk, and so when anybody says security, you have to ask, what do you mean by that? I've come up with 11 meanings of security. There are the 3 A's of security to which I've added access control. There are the things that are normally done with crypto, and then the things related to, can I actually use my machine? In other words, am I safe from denial of service by sledgehammer? Now, no security person, no security project can be expert in all of these, yet every security architecture must cover them all. So when I say security, I'm going to tell you what we mean. We largely focus on access control. You'll see that we touch on some of the other things, but our primary focus is on access control. So here's the outline for the talk. What's the problem? Well, on my computer, on many of your computers, there's this very powerful program. This program can erase files. It can search looking for secrets and sell them to the competition. In extreme cases, it can even reformat your hard drive. Yet, there are employees at my place, and I'm sure there are employees at this place, who use this program at work every day, some of them for hours at a time. Would anybody care to venture a guess for what this very powerful program is? Any guesses? Huh? All of them. Sorry. All of them, he says. Exactly right. This one can do all of those things. Now, why does Solitaire have the power to reformat your hard drive just because you're running as administrator? I mean, it's a ridiculous authority to give it. Why can it plant a Trojan horse in your startup folder? Well, nobody ever said that Solitaire did, but the fact that it can is the root cause of many of our problems. The reason this happens is because we use identification or role-based access control. You log into your computer and you get your identity, and then every process you start runs with that identity. And that's a good way to keep you from doing something you're not allowed to do, but it doesn't prevent a program acting on your behalf from doing something you're allowed to do that you don't want done. That's what the viruses do, right? They do stuff you're allowed to do that you don't want done. We think a better approach is to enforce the principle of least authority. Give each program only the authority it needs to do the job the user wants done, and then you don't have to worry. And it really recognizes that we give privileges to people, but we can only control access on processes. Now, this approach has been used many times in the past, and it's always failed. Even the NSA gave up on it. The reason is it's viewed as a usability nightmare. You keep getting these pop-up dialog boxes, may I, may I, may I? It's a denial of service attack against the user. So the key insight here comes from Mark Stigler's work on CapDesk, where he noted that when I want to edit a file, typically I'll do something like double-click on the icon for the file. That's an active designation that I have to do no matter what. His key insight was that the system can also use that as an active authorization. And when we do that, we find that almost all the security decisions disappear into the background, the actions you normally take anyway. And you'll see that in the demo. Now, today's approach is, every time there's a new kind of attack, an Excel macro that does something bad, don't use macros, love letter, well, don't use email attachments. Every time there's a new class of attack, we're told not to do something else. So when we get the next class of attacks, I fully expect to see this be the recommendation. Right? I mean, that's what it's going on here. This is feature starvation. There's good reasons why we want to do that stuff. And we think that especially dynamic POLA, where the authorities can change as the user wants to do different things, is far better than feature starvation. It lets you use the features. There will still be some risk, but at least you get to use the features while you limit the risk. Now, the group consists of 5 people. You're going to hear 4 of us during this lecture series. Me, Mark Miller next week, Tyler Close the week after, and Mark Stigler the week after that. And we've worked on, or are working on, a number of different projects. And what I asked everybody on the team to do, including me, is for each of those projects produce 3 slides. And just to make it a little bit harder, no more than 50 words total on all 3. Okay? And sometimes that's straightforward, and sometimes it's a really hard thing. You can ask Tyler how hard that is, because we all sweated a couple of weeks over getting one of his sets of 3 slides. Now, even at that limit, I don't have time to go through all of these. So what I'm going to do now is I'm going to give you a brief summary of each of these projects, and then open it up to the audience and show you the ones you want. And if you don't choose, I will. And about 15 minutes before the end, we'll stop and I'll give you the demo and wrap up. Okay? So let's start at the top. Mark Miller, who you're going to hear next week, has spent the last 6 or 7 years working on the E language. Now, he calls it a language, but it's far more than that. It's a full distributed secure runtime system with some very interesting ways of dealing with concurrency. Mark Stigler used the E language to write CapDesk, which is a desktop environment. It looks like any other desktop with icons and menus and all that kind of stuff, except it's inherently secure and distributed, and underneath it is a secure distributed file system, but just transparent. You just work on your desktop as you would normally. Mark Miller and Mark Stigler formed a company that got a DARPA contract. The DARPA wanted a browser that they could use in the Pentagon where the rendering engine had been written by the Chinese army. Browser to use in the Pentagon where the rendering engine had been written in the Chinese. That's quite a challenge. These guys succeeded. There was a security review, there were some bugs, but overall, they succeeded in building such a browser. That's the DARPA browser. How many people here know about Planet Lab? A few people. Planet Lab is a consortium of about 60 universities, 10 companies. They've got nearly 1,000 computers scattered around the world. And if you want to do an experiment in large-scale distributed computing, and you're not at Google, you can go ahead and sign up and get a piece of each one of those 1,000 machines. So it looks like you got 1,000 machines to yourself. So for example, Ocean Store is one of the projects being run on Planet Lab. Well, we had a security review of Planet Lab, and they came in and told us about it, and the first thing we noticed was there's a Planet Lab Central. Now, security guys panic anytime they hear central. Central point of failure, central point of vulnerability. So Mark Stigler, Mark Miller, and Terry Stanley, about 2 years ago, a little more than 2 years ago, took a Memorial Day weekend, a 3-day weekend, and they built essentially most of what's the important part of what's in Planet Lab, but without a center. So they call it Donut Lab, which is Planet Lab without a center. And the interesting thing is because they use E, they only needed about 12 pages of code, and that included their test application. So that's an impressive demonstration of what you can do with the E language. A number of years ago, I was involved in an HP product called eSpeak, and that's no longer being offered as a product, but we learned some important lessons. One of them was that you need to consider structural security. In a distributed system, you have certain components, and they can be plugged together in different ways. Some of those ways actually make it possible to secure your systems, and others don't. And you need to study those. And we learned some lessons, and that's what structural security is all about. Okay, what do you do with your passwords? Well, it's a big mess, right? You got them in your head, which means you only have a few and they're low entropy. I think one of the best things you can do is write them down and keep them in your wallet, because I never heard of a pickpocket who hacked computers or a hacker who pickpockets. But I worried about this problem, and a few years ago, I came up with a little tool that lets me calculate my passwords rather than remember them. So I only have to remember one secret, and I can get strong, different passwords for every place I log in. That's the site password tool. Phishing is a big problem. Farming is a problem. What are we going to do about that? Tyler Close realized that the essential problem was that you were being asked to make an important decision based on information provided by the attacker. The attacker chooses the URL, the attacker chooses the look and feel of the web page. So he came up with the pet name tool, which is available for Firefox, that lets you see information provided by you. And if you don't see that information, most likely you've been phished or farmed, and you know to be very, very careful. Ka-Ping Yi, who's a grad student, fifth-year grad student at Berkeley, be finishing up, I hope, soon, took these two tools and put them together in a way that one user said it has changed his life. He no longer agonizes over passwords. It's a good example of part of our philosophy, which is improving the user experience by adding security. Improving the user experience by adding security. We have about 15 users at HP Labs, most of whom use this tool because it's easier. They don't even care that they're more secure. Ping is also an expert in interaction design for security. He's written a couple of book chapters on this subject, and he's come up with 10 principles for secure interaction design. Tyler, again, looked at the problem of composing services on the web, not necessarily web services in the sense of SOAP, but how do you put things together on the web in a reasonable way so that it's manageable and understandable and securable and all that. And he came up with something, we're thrashing around on the name, the current name we're using is WebKeys, but the basic idea is you can compose web services with very little or no glue code, and that's the idea behind the WebKeys. Tyler also had a consulting business in a former life when he was living on the beach in Anguilla. And I don't know if you know this, but the oil tankers at sea, the oil on them, changes hands several times between when it's loaded and when it's unloaded. And those contracts have a very complicated protocol. And Tyler, again, identified the essential thing, the key point that was making those protocols so complicated, and came up with the IOU protocol, which the IOU protocol is simple enough to write down on about a page and a half of text. So he greatly simplified it by identifying the key source of the complexity. And then I've been working with the Navy. The Navy is trying to turn the DoD into a whole bunch of web services. They're using the services-oriented architecture and the web services standards. And I looked at what they were doing, and I was giving this presentation to a group of high-level managers, program managers. These are the guys who wouldn't even consider writing a check for less than 300 million, right? You know, little stuff like that for the government. And I told them, by the way, before I start, what you're doing ain't going to work. I can tell you why, and I can tell you how to fix it. And so over dinner, I told them why, and I told them how to fix it. And 2 weeks later, their consultants came back and said, it's not working, and they said why, and it was exactly what I told them. So now I go down to Monterey every once in a while to tell them how to fix this stuff. And that's what this ABAC is all about. And then the demo, the virus-safe computing environment. So that's the overview of the projects. Anything that you'd like to hear about in particular? Anybody? Otherwise, I get to choose.
I know you.
Go ahead. Yeah.
NSA added code to Linux to sort of bring this sandboxing.
So NSA added code to Linux to sort of do sandboxing. That's called, HP has a product on that called NetTop. And this is for the multi-layer level security. The way it works right now, you've got some private in the Army. Actually, I'm dealing with the Navy, so you got some seaman in the Navy. And he's dealing with highly classified material, somewhat classified material, and confidential material. And he's got 3 machines on his desk on a submarine. Right? You know, they don't got a lot of space on the submarine. And in fact, worse than the machines on the desk are the holes you have to drill in the bulkheads to get the cables through. That turns out that's a bigger problem for the Navy. They got very limited space there. So the NSA developed this infrastructure based on virtual machines, VMware, where you can have one machine and run 3 separate compartments. NSA has certified the code that they can't crosstalk. That's what NetTop is. ABAC is something different. It's a completely different way of thinking about how to do security. So since you're my host, I'm going to take his question first, and I'll explain to you a little bit about that. Besides, this is the work I'm doing, and I'd rather talk about my stuff than theirs. So, but I'll get to it. All right. So let me start with a sad story. You can see what happens when they give you a new format. That's a little too close to the bear, but I have to edit my slides. Let me tell you the sad story of ZebraCopy. This is a true story. ZebraCopy was a mom-and-pop copy center in Palo Alto down at the corner of Page Mill and El Camino. They were so small that when business was slow, they'd dress up one of the employees in a zebra suit, stand out and wave at cars. When my son was little, he liked that. Well, they had a contract with HP, and about 2,000 HP people had the right to order copy jobs from ZebraCopy. And so when an order came in, ZebraCopy would look at the name on the order and check it against their list. And if the name was on the list, they'd do the job. Right? And when an employee changed jobs, HP would just send a note down to ZebraCopy and they'd update their list. The first time I heard this, I thought it was a joke. I mean, it's the way we do things, but it's a joke. Why is it a joke? Well, at that time, HP had more than 10,000 small business partners like ZebraCopy. And ZebraCopy had maybe 500 or 1,000 clients in the Valley like this. Right? So they must have had a full-time person doing nothing but updating these lists. It was a nightmare. Right? Now, they're out of business now. I don't think that extra person was the only reason they went out of business, but it sure didn't help. So what was going on? So let's say Bob was one of those people at HP who could order copy jobs from ZebraCopy. So Bob would send a request to ZebraCopy. They'd look up his name in their policy database. You know, maybe you could only order black and white jobs and not color jobs. Get back the result, and if he was authorized, then they'd send the job back to Bob. Okay? Very simple, very straightforward. But it turns out there's a number of problems. First of all, how does Bob's name get in the ZebraCopy policy database? What if there's already a Bob there? Does he have to be Bob Q or Bob X or Bob Z? How many identities do you have on the internet because of such problems? Also, Bob had to be able to authenticate. He had to learn how to log in. That's why we have so many passwords. Look at how it worked. We have the problem of ambient authorities. When Bob makes a request of ZebraCopy, they look at the request and they look at the sea of all the things that Bob is allowed to do. And if there's a match, they do it. So if Bob intended to just check his account balance and inadvertently do a programming error, an input error, ordered 10,000 copies, 10,000 copies get ordered. Or if the program Bob was running had a virus and Bob intended to just check his account balance, the virus could order 10,000 copies. So there's a lot of chance for confusion. There's no convenient way in this picture for Bob to give a program a subset of his authorities. Bob goes on vacation and he needs Carol to take over for him. How does he do that? Well, he can tell HP to add Carol to the Zebra copy database. That's one way. Of course, that takes some time, and it's awkward, and it's a problem. Having done that, let's say Carol does something wrong. You've lost track of who was responsible for Carol's actions. Right? Bob was the one who said she could do it. Bob ought to share in the blame, but you've lost track of that. So what normally happens in this case anyway is it's so hard to let somebody else take over part of your job that you just let them take over all of it and you give them your password. I don't know about here, but at HP, every manager has given his or her admin his or her password, right? Because you can't give part of your authority. You need them to have part of your authority to do your job, so you give them all your authority, and now you have to trust them. Very bad situation. Bob gets back from vacation. How's he going to do the revocation? Well, he tells HP he's back to revoke Carol. HP sends Zebra copy a message, says remove Carol from the database, but what if Carol was already in the database for another reason? Oops. How do you keep track of all this stuff? And finally, there's a very important vulnerability that is widely overlooked, which is the confused deputy. Let's say that Bob doesn't make the request directly, but HP does. It's quite likely that HP can do more things than Bob is allowed to do. So what if Bob asks HP to do something that HP is allowed to do, but Bob isn't? HP might do it, right? So how do you prevent that? Well, HP has to check Bob's authorities before it acts as his deputy. But that means every service that acts on behalf of somebody else has to build its own access control mechanisms. And that's just not a recipe for success. So here's what we propose. Authorization Based Access Control. Now, it's not much of a change. I've just moved 2 lines on the architecture diagram. What's going to happen is when HP signs the contract with Zebra Copy, Zebra Copy is going to give HP a bunch of authorizations, independent authorizations, one for each action covered by the contract. HP is going to put them in its policy database. When Bob logs in, and he only has to log into HP, he will get back a bundle of authorizations, all the things he's allowed to do, within HP, with Zebra Copy, with other business partners, just a big bundle of them. And now when Bob wants to order copies from Zebra Copy, he'll give that running program the exact authorization it needs to do the job he wants done. That's POLA, Principle of Least Authority. Has a number of advantages. Remember, there was no trust relationship between Bob and Zebra Copy. It was Zebra Copy to HP, HP to Bob. And this makes that explicit. And making trust relationships explicit is always a good thing. I'll get to delegation, but revocation is manageable. If Bob has delegated one of his authorities, he can just revoke it whenever he gets back from vacation. It's a very simple thing, very easy to do. You'll notice that Zebra Copy is now out of the business of managing HP employees. So we've taken this n times m problem and reduced it to an n plus m problem. That's another big win. And furthermore, it has privacy implications because now nobody else has to know when HP has a reorg or when somebody changes jobs or gets fired or whatever. This is pretty important when you're talking to the military in particular. Oh, isn't that nice? Okay. Should we run my backup now? Maybe not. Oops. It's easier to upgrade the system. If Zebra Copy has a certain format for the authorizations, right? Zebra Copy is the only one who looks at what they mean. So if Zebra Copy wants to add a field to the authorizations or change the names of the authorizations, they're the only ones who look at it. As far as HP is concerned, it's just an opaque bag of bits that they know what rights it grants, but they don't have to know how those rights are expressed. So if Zebra Copy wants to do an upgrade, they just do an upgrade. Yeah?
So you said revocation is manageable. Let's say Bob is delegated to Carol. Carol can now do replay attacks.
So if Bob is delegated to Carol, Carol can now do replay attacks, and it depends on the technology you use. And I am not saying anything about the technology you use. The whole point here is to get you to stop asking, who are you, and start asking, is this request authorized? Everything gets simpler when you do that. Okay? And finally, distributed policy management is viewed as a very hard problem. I actually think with explicit authorizations, with authorization-based access control, distributed policy management is quite straightforward because it just follows the way we do things anyway. HP signs the contract with Zebra Copy, gets a bundle of authorizations. Bob manages the graphics arts department, so they give him the authorizations. He delegates them to his people. They delegate them to their people. It's just the way we've managed companies for hundreds of years, and it just works. And we don't need a whole lot of infrastructure to make it work. So that's the story on authorization-based access control. In fact, I was just at the TIPI workshop at Stanford, and there it was, how do you prevent all these authorization attacks against our authorization systems? And the question is, why are we asking people to authenticate so many times? That's opening you up to phishing. Look, when you set up a new account at a bank, you get a URL that you can bookmark, right? Well, why does that URL take you to a form where you put in a user ID and password? Why doesn't that URL just take you directly into your account? And the URL is just a big secret, like a big random number. It's a moral equivalent of a password, but you don't have to remember it. It's just a web link, right? So why don't? So yes, we can go to all kinds. We consider that, and we understand how to deal with that. There are ways to deal with that. For example, the bookmark can be encrypted in the browser, and you can use a SOX proxy to do the decryption to send it to the bank. Right? There are ways to deal with these things. But the point is, I can do keyboard sniffing, I can do phishing, I can do all kinds of things if the bank link takes me to a login page. The number of attacks and the way of implementing them is much harder if I just have a bookmark. And by the way, it's easier on the user. So, and it can be made more secure. So let me just go back. Okay, what else? Site password, okay. So as I said, too many services require login. We haven't changed the world yet. We'll get there eventually, but we haven't changed it yet. So either you have one or a small number of passwords, or you have a different password for each site. If you have a different, I just counted, I have 55 places I log in. I'm not going to remember 55 different strong passwords. So I mentioned the piece of paper in your wallet. There are these password managers. Firefox has one built in and you can buy these things that keep them encrypted on your machine. But then how do you get your password when you're not on your machine? So what are you going to do? So I just wrote this little tool. You have one password, one strong password you have to remember. It's subject to a dictionary attack, so it needs to be a strong password. You have an easy-to-remember name for the website, and they just get hashed together to produce a password that you can cut and paste into the field. Okay? We have a version. You can get it off the HP Labs download site. By the way, if you're not at your own machine, you can just go to my web page and run the program on the machine you're sitting at using the executable sitting on the web, right? And so you can get your passwords wherever you are. We've actually identified a number of other uses. For example, role-based access control, right? We can use the name and the role as part of it to put them together in different ways. We've actually used it for symmetric key management. When Mark Stigler first joined HP, he actually lives in Arizona, comes in every second week. And he couldn't get through the VPN tunnel. It turns out his ISP had some port closed. And so we just set up a symmetric key with a shared secret that we shared when he was visiting one time. And then we were able to change the key by just updating the one field with the month, which could be in the clear. Or we could just tell each other openly about the second part. With a slight change on the server side, it can be used to generate one-time passwords. And one of the things left out of the wireless equivalent protocol was key management. And this tool can actually be used for web key management. Yeah? So is there a simple way to change your master password without changing all of them? No, but there's a simple way to change one password without changing them all, which is just change the name. So Schwab makes me change my password every year. So just a couple months ago, I switched the site name, this thing, from being Schwab 2005 to being Schwab 2006. That can be public information. So I actually have all my site names and user IDs actually on my public website There's no link to it, so I know where it is and you don't, ha ha ha. But if somebody got that, it would give them very little security information, except for Schwab, where my user ID is my social security number. So that's not listed, but in general, it's just there. So, yeah. So yes, so are you more vulnerable to a keystroke logging attack? So what I do is I have site password in my startup. So when I first log into the system, when I'm least likely to have at least a hook-based logger running, I type in my master password. After that, there are no keystrokes to log. Okay? So if I'm going to log in from another computer, that's always dangerous. Take your chances. But if I'm at a friend's house, look, I bought these shoes standing in the Sony store at Stanford Shopping Center. Okay? I was over there, my wife was shopping, I was bored, I said I need my shoes. So I went to the place where I'd bought them before and I needed my password. Okay, I'm standing at a computer in the Sony store. What is the risk that they're going to get my login, my master password, and know what to do with it, quite frankly, because nobody else knows about site password. So I just ran the thing and got my account, got my password, logged into the site, and bought my shoes. Okay? You have to manage your risk. Why are you logging in from somebody else's machine anyway? Right? There are plenty of things. There could be a hardware keystroke logger there, right? So you manage your risk. So in this case, I managed my risk. Yeah. Okay?
It seems like this sort of an app that could be put into a portable device just for that purpose.
Absolutely. There are many ways you can deal with it that make it easier. There are plenty of things once you have the idea. And this is just hash-based passwords. It's just an MD5 hash of the secret and the site name. So, yeah. Sure. You're going to hear more about this next week, right, Markham?
Yeah.
Okay.
Well, I wasn't spend time to just focus so much
Yeah.
on language as the general concept.
Right.
Proper language is good.
Yeah. So we've wanted to have electronic cache for a long time, right? But we don't have it yet. So it must be very hard to do. I mean, there's a lot of money to be made if we could have electronic cache. I'm not talking about micropayments, but just electronic cache. So this is the problem. You can see, again, the problem with the new style on the slides. I got to go back and double check them. So this was the problem that I think Markham started out to solve, which is why he got into this racket. No? Maybe, sort of. At any rate. So it must be very complicated. So here's the situation. We have Alice and Bob that have accounts at the same bank. Alice wants to pay Bob $10. I'm going to show you the E code she needs to do that. So the first thing Alice is going to do is make a purse. Now she's got the handle to an empty purse. And then she's going to she's going to deposit $10 into her purse. And you see it gets removed from the bank. Then she's going to hand the purse to Bob. Now Bob has the handle to the purse, and then Bob is going to deposit the money into his account. Now, you would think this would have to be very complicated with all the things that could go wrong. Money could appear, money could disappear, Alice could cheat the bank could cheat Bob. I mean, there are all kinds of things that could go on. But here is the totality of the E code you need to do that. Even when Alice and Bob in the bank are on 3 different computers talking over the open internet. Very simple, because the proper way of thinking about security was built into the language at the very beginning. What about the bank? That must be a real mess, right? If it's so simple for the clients, the bank must be a real mess. Here is the total code you need for that transaction. Now, it's not really a bank. There's no auditing, no SOX compliance, all that other stuff. But it's all the stuff you need to make that bank work without any chance of money disappearing or the bank being cheated in any way. Okay? And it fits on one slide, not a page of code, but one slide. Again, that's because Mark Miller thought about all the implications of the security actions that he was taking. Basically, this is ABAC at the level of the individual object. Okay? Now, if you think that you need to learn a new language and learn a new runtime system in order to make this work, you don't. It turns out that what he is doing is just good object-oriented code design. throw away all the things that break the object-oriented model, and you'll almost be there. And so, in fact, there's a project called Joe-E at Berkeley that's providing a filter to verify that you're using the proper subset of the Java language. But since it's a subset, any Joe-E program will run as a Java program. It's just a subset. And the verifier they're writing makes sure that you don't use any of the bad stuff that you shouldn't have been using anyway. Okay? So you can actually use Java to get this level of security. Now, it's a bit more verbose, and you can see there's some funky library calls. So you can use E for the simpler. It's hard for me to say this without choking, the simpler syntax. But in this case it is. Yeah, we have syntax arguments all the time. Yes?
What happens to the first when an exception is thrown?
What happens to the purse when an exception is thrown? We haven't shown that here. Let's see. What exception would be thrown here? Yeah, well, just tell me quickly, and I'll...
Okay. So,
and I'll repeat it.
The crucial method is the deposit method. That's the one that transfers money. And the critical issue is that if the two purses are purses from different currencies, or if one is not a legitimate purse, or there's insufficient funds, any of those things will cause an exception to be thrown before money is transferred at all. Once you've gotten past all of those checks, now you're in code for which there's no opportunity for exception.
So,
the only thing left is the decrement and the increment.
So let me repeat that. For this simple example of one bank where there's only one currency, if the purse is a legitimate purse, there are no exceptions that can be thrown once you get to that point. Okay? But if there are, then the exception code would deal with putting the money back in the accounts. So for example, if Bob did some operation against the purse that was invalid, well, Bob would get an exception, but the purse would still be there. Okay? But there are no exceptions. This is why it's very careful to use things like branding and the methods that the arithmetic in E is always using non-overflowing arithmetic. So the number of exceptions, and in this case, there are no exceptions that can be generated. But if there's an incompatibility in the purses, you put in dollars and I try to pull out euros, then the exception will be thrown, but nothing bad happens to the purse. If the bank crashes, E is replayable from previous state.
So the key thing is that synchronization-wise, the only states made persistent are the states. There's an implicit transactional model here. The only states made persistent are the states between transactions. So if you crash and you come back from your last persistent state, you're always in a consistent.
Right. It's inherently transactional in that sense. So okay.
I'll be talking somewhat more about E in my talk.
Okay. So let me go to the demo. Okay. Now. HP Labs has lots of various projects. One of them is the nanocomputing. Have you heard about this? Where they're making individual circuit elements out of molecules, one molecule thick, switching and transistors and all that. They built the densest memory by a factor of 30, right? It's I've forgotten how many gigabytes per cubic millimeter or square millimeter or whatever it is. But and they got 64 kilobytes of it. But at any rate, one of the things you may not have heard about is their work on a molecule called thiotemelene. Thiotemelene is a molecule made up of 4 carbon atoms. It was discovered in the early 60s by Isaac Asimov. And what it is 4 carbon atoms in a tetrahedron, and it's been rotated in 4 space so that one of the carbon atoms is 1.3 seconds in the future. And our guys have figured out how to chain these things together, sort of like a carbon nanotube, so they can see an arbitrary distance in the future. Okay? And they built a spreadsheet that will calculate, not predict, but calculate the value of my stock portfolio 10 years from today. Now, okay, good. Sometimes I give this talk to rooms full of executives and nobody laughs, and I get really worried about my stock portfolio. Okay. At any rate, they're physicists and chemists, and they don't know much about computer security, so they get a lot of viruses. So what am I going to do? So let me run this spreadsheet for you. We, oops, get set up here. We call this, spreadsheet killer.xls because it's the killer app, right? This is the ultimate killer app. So the first thing I want to do is I want to open it the way I would open it on the way you would open it on your machine today. Okay? And the first thing you get, of course, is a stupid dialog box. Dialog boxes need some translation. This one is saying, do you want to get your work done and risk your whole machine or not? And really, that's all that it's saying. And we say, of course, I want to risk my whole machine. Really, what we're saying is we want to get our work done. OK, $100 invested in HP, 10 years from today will be worth $133,000. Hey, I like that. Okay? We don't know the rate of inflation. It might not buy a double tall latte, but and by then Google will be charging for lattes. Don't worry. How about $100 invested in Microsoft? And I have just been bitten by a virus. And this virus is in the process of eating up my desktop. Watch back here. Right? And because it's eating my desktop, it could eat up my whole machine. Right? This is very bad. Kablooey. Right? This is not a good situation. So, fortunately, the virus is either very stupid or not really malicious. Because it didn't destroy my stuff, it just hit it. So what I'm going to do is I'm going to put it back. Rearrange things here. And now what I'm going to do is I'm going to launch it under Polaris. I'm just going to double click. Okay? This is the active designation. We start Excel with the authority to edit no spreadsheets and add the authority to edit the one I just designated. Okay? So we have an error in our virus, and I'm going to have to relaunch this. Isn't that interesting? The virus has a bug. We'll see how we how we deal with those later. It's a timing error that we haven't found since the last update of Office. So let me try one more time. I'm going to pause, give it time to think. Settle down, virus. One more. OK, if it doesn't work on this one, next time I'm going to give up. What will happen is it will just run. The virus will show me that it has no files it can edit. No, the virus has chosen not to run. Let me just, and it's dead. So what happens is that window comes up, says I've been bitten by a virus, and it shows me no files. The virus didn't need the authority to edit any files, so it didn't get any authority to edit any files. That's the problem. Yeah? I'm sorry, what?
You mean Excel didn't get the authority?
I'm sorry, Excel didn't get the authority. So normally when you start Excel, you start it running as you, and you give it a string representing the name of the file you want it to edit. Excel has to be prepared to edit any file you might name, so it needs all your authority. We started with the authority to edit none and add the one you just designated. Sorry about that. I ran the demo just before the session, but the virus decided to die. Yeah. Right. So that's a good question. What about the config files and everything else? Obviously, Excel needs its own executable. It needs its fonts. It needs all kinds of stuff. But those are things it needs every time it runs. So we call that the installation endowment. You configure that once when you configure the application to run under Polaris, and then it just gets those authorities every time. And we have a little tool that configures the applications. For most applications, it's very straightforward. We haven't run into any that it's more than one or two exceptions. Yeah?
So is it possible to transition authority to Excel?
Yeah. I'll show you that. Since you asked, we'll give it one more chance. No, it's not going to do it. OK. But if I want to open another file, now watch closely what happens when I do this. I'm going to click the File Open dialog box. You see that flash? That was the file dialog box that was running with the permissions of Excel. We watch for that file dialog box, hide it, and present one that's running with my permissions. Now I can select any other file and give this running instance of Excel authority to that file, right? And the virus doesn't have access to that window, that full power dialog box. Only user does. So what we're finding are acts of designation that are available to the person, but not the virus. And as soon as we have that, we can implement the function. So we have a little service running in the background that's watching for that dialog box. Yeah?
So although in that particular case, the file dialog box didn't appear to be decorated, right?
Yes, it was. It was very most. You notice how this one is decorated with the angle brackets Excel. So I know that that's running in what we call a pet because I've given it a pet name. You see, this says open for Excel. It's not just open, which is better than the standard file dialog box. It actually tells me which application, which running pet is asking for this file.
Are you going to do anything more than that? Because for the average user, they're not going to...
The average user probably won't get in trouble, but usability is more important than small increments in security.
There's an additional point I'd like to make there.
Yeah.
Which is, let's say that the application opens its own dialog box that we don't intercept. The result is that the application has failed to acquire an authority that the user would like to give.
So let me repeat this for the people who are remote. If the virus opened the file dialog box, it only has access to the one that's running in the confined space. So the user might not, if the one we just showed was hidden or didn't show up, the user wouldn't be able to grant the authority, but that fails safe. So, but that's not your question, yeah, right. Well, in this case, we do this for file dialog boxes. Okay, and we do label it. We do the best you can. I don't know what we can do. Maybe we could have a sledgehammer that says no, no, no. But how do we know if it was, viruses can inject keystrokes. So how do we know if it was the user who clicked or the virus? Only the user knows. So if a file dialog box pops up surprisingly, maybe you shouldn't open a file. But you probably don't know which file you want to open anyway, so maybe you won't. That's the best we can do. Yeah. What about access to non-file things? So one of the things we would like to do is prevent certain applications from getting access to the internet. Our original plan was to just use the firewall to do that. Unfortunately, every firewall we've looked at has rules for preventing network access by application, but not by user account. And that's too bad, right? Because we'd like the main user account to have full access to everything the user wants and limit the pets as needed, and we haven't figured out how to do that yet. So we have several proposals, including our own SOX proxy running on the machine and blah, blah, blah. We haven't done that so far for the beta. Let me go on and show you, I have a couple more short demos. Okay? One of the main sources of spyware is the browser, right? So here is a website that will make my disk shine like new. Now, I'd like to have a shiny new disk, so I'm going to go to this website. And of course, you get a crazy dialog box. This one is saying, do you want a shiny new disk or not? Because that's what you asked for, and of course you say yes. And now I have a shiny new disk. Of course, I've got spyware all over my machine. In this case, it's just on my desktop. That's because the browser is running with all of my authority. Now, Windows Vista is going to provide some protection from that, but not enough. How about if I go to that same website in the browser running under Polaris? First thing is I don't care about the dialog box. I can just let it go, so I don't have to be bothered by that. And of course, there's no trash on my desktop. This is actually the virus on the previous run failing. The virus on this run failing. That's good. It's good that the virus failed. Some of them failed quietly. A third source of trouble is email attachments. Right now, most corporations are filtering most kinds of email attachments. And yet here I have this very important email. It's the crucial Windows virus update, right? It's very important that my viruses be up to date. Wouldn't want an out-of-date virus. Well, we've seen the problems with out-of-date viruses, right? They don't run. You're not allowed to send an executable through the firewall, so what do? Well, you put it in a zip file, right? In fact, the instructions on the HP website tell you to do that. Talk about shooting yourself in the head. So I go to launch the virus, I get a stupid dialog box. I go launch the virus, I get another stupid dialog box. These things are like teaching a pig to sing. The pig isn't going to, it's going to waste your time and just going to irritate the pig, right? And at the end of the day, the virus is run and all my friends and neighbors have been infected. Now, we couldn't get our mitts in to grab the double-click launch here. So what we did is we added a button We teach our users to launch attachments with this button. And this is going to run them under Polaris, so no stupid dialog box. And when the virus runs, it doesn't have the authority to do anything bad. And we've set up that account to have one entry in the context list, which is the local sysadmin. So your whole environment becomes a honeypot. Okay? So those are the Polaris demos. Sorry, the spreadsheet didn't work. Yeah?
I think that still gets to the point where someone knowing that this virus protection system is in place will just offer a message that says, you can't get this great feature because you're running on...
Right. So if I were going to attack the system, I would write a virus that made the application look like it was running strangely to induce the person to open it outside of Polaris. And the only thing we can do is make sure that nothing will happen strangely while you're inside Polaris. When people get confidence in it, what we tell them to do is, if it's acting strangely, is open up some other file that does something similar outside Polaris and see if it still acts strangely. And then you know it's something in the file and maybe you should be suspicious. That's the best we can do. But yes, that's exactly the attack I would mount, and that would succeed some of the time. But there are some people who answer Nigerian letters, and there's nothing we can do about that, right? So we do the best we can.
This is sort of a big question about the actual.
Yeah. So what's the implementation? What layer are we doing? We are using a variant of the Windows Run As system. Each application, we set up a separate account running as a restricted user. When you double-click, and we changed the file associations so that when I double-clicked on that .xls, instead of it running Excel directly, we did a Run As Excel in that restricted user account. That's it. After that, it's just running, and we're out of the picture, except until the file dialog box appears. So we didn't touch the application. We don't change. We're not running at any layer. We're not intercepting system calls. We're just using the normal Windows API and the Run As facility that they already provide. So let me just wrap up now. So what you just saw was more functional because you could use all these features. It was easier to use because you didn't have those stupid dialog boxes, and it was more secure at the same time. Most people would say you'd have to pick 2 out of 3. You just saw all 3 at the same time. It actually blocks today's viruses. I mean, the macro viruses, all kinds of things, right? It just blocks them, and it's easy to use. This presentation's being done under Polaris. Some people have said use a Mac because it's safer, but the same kinds of viruses will run on Mac, and when enough people did it, there'd be viruses for the Mac because Mac uses identification-based access control. But with Polaris, you get to use your existing tools. You notice it's Windows, so I didn't say that you know and love. I just said that you know, right? But you get to use them, and you're safe from these a whole class of attacks. Somebody would have to come up with a new class of attacks. Now, we don't protect against attacks against the kernel. So, but in that case, you know, when Blaster came out, that was an attack against the kernel. We would provide no protection against that. Microsoft's response is, here's the patch. When Love Letter came out, there's nothing to patch. The system is operating the way it was designed to operate. So what was Microsoft's response to Love Letter? Buy a smarter user, right? There's just nothing they could do about it. This is the one that Polaris addresses, so it's complementary. And it forces Microsoft to be responsible for bugs in its system. You know, virus scanners are fighting the last war. They can only stop a virus that they've seen before, and now the attack time is dropping. Firewalls are a great idea. I mean, I recommend them. They're fine, except the first step in a perimeter defense is actually having a perimeter. Microsoft's approach, you know, the trustworthy computing initiative with quality assurance and patching, that's a good thing, but if that's all you do, you only win if you achieve perfection, because as long as there's an exploitable flaw, it will be exploited. What we're doing is saying, how can we reduce the exploitability of flaws that will already be there, right, to limit the damage that can be done? That's a good complementary question to the question, how can we prevent an attack from succeeding, which is the conventional question asked by security experts. And finally, here's a quote from a smart person who happens to be very lazy. That's me. Okay? The best way to solve a problem is to avoid it. If we give processes only the rights they need to do the job the user wants done, we can limit the damage a virus can do. maybe to the point where we've made virus writing uninteresting. Okay, now I got 2 more slides. First of all, what's this bear? No guesses? Of course, it's the polar bear, right? It's the polar bear. Why is it Polaris? Well, that's the principle of least authority for real internet security. I have a PhD in astronomy, and every astronomer knows that the big bear points to the North Star. So that's why we call it Polaris. We have a tech report, which is available now, and we have just been found out we've been scheduled for the September issue of CACM. So if you want to read more about it, you can read the tech report or wait for your CACM to come out. So that's the end of the first of our 4 presentations. Any more questions? Okay. Sounds like we covered it. I'm sorry, what?
Can you download Polaris?
Can you download Polaris? We have a beta test program. You have to sign our beta license agreement. You notice we didn't sign your non-disclosure agreement. Maybe you can't sign our beta license agreement. We're actually, a week ago, let's say a week ago, 2 weeks ago tomorrow, we will have distributed our beta to our original test set. We're trying to get the bugs out of that. Within the month, we'll be looking to expand the beta program. Send me email if you're interested, and I'll send you a copy of the license agreement for your lawyers to look at. So that's the big barrier, it seems. But
when you're, sometimes these macros do useful things that are going to get prevented. I wonder how is the user supposed to allow?
Sometimes these macros are going to do useful things that will be prevented. Actually, this won't prevent them, because you're going to let you run the macros in Polaris. If it fails, it probably should have, because it's trying to use authorities that the user didn't grant it.
How do you grant it?
How do you grant it? Well, mostly it's through the file system. So if the macro needs to use a file, it's going to have to ask the user what file, right? And if it asks the user what file, that'll be a file dialog box, and then the user can grant the authority and the virus can't. That's the primary step. Sometimes there'll be other dialog boxes that are non-standard, and we have a workaround for that, but it's just a workaround. That's the advantage of doing the beta, not the product. Yeah?
So could you summarize very quickly when you said about mapping concepts from E into Java, what is the unsafe subset of Java?
Primarily, it's avoid using mutable static state. So if there's any global state, it must be immutable. Now, when I was learning object-oriented programming, I got myself into a lot of trouble. And I identified the source of the trouble, just for me, personally, for my own use. And the main thing I was getting in trouble was I was using mutable static state. And I realized that that was violating the object model. And so just good object-oriented design seems to be 90% of the way. Okay? Thank you. I think our time's up anyway.